Okay, students, we are unable to wait. We will start our session. Very good afternoon and warm welcome to all the students who joined this industry-oriented course, Electronic Simplified Practical Approach session. Actually, where we are moving in, what is our next goal? Okay, so first we will discuss regarding that because last class we don't had this particular IOC hour due to your internal test because you had your coaching class for tomorrow's exam. I mean for Thursday's exam. So that's why that has been cancelled last week. So we are in first module, and today I am focusing to complete first module. Okay, so in the first module, last class, what we have discussed is regarding sensors and switches. We have discussed some points, and today we will be discussing remaining three as per our plan. Number one, we are going to discuss about relays. Number two, we are going to see some points about multimeter. And finally, we will be focusing towards basics of soldering. After completing all these things, as usual, as it is a Google Meet link, you please wait for giving attendance. Once you have given the attendance, with my approval, you can leave the class after giving the attendance. Okay. So this is the plan, and by today we will complete our first module, right? So with this small input, a brief input, I'll share the screen. One minute. Yeah, is the screen visible?
Yes, sir, visible.
Okay, thank you. So let me make screen 1 minute. So our focus for today is module 1, relays, multimeters, and basics of soldering. As usual, I request all of you to make some interactions, and also if any points other than what we are discussing, that also the forum is open to you. You can also share some inputs to me as well as the other students. So if any point I failed to or I missed out, that you can tap. So this is the agenda for today's session. This revision of the previous class. What I have done so far, we have done is the revision. So relays we will start up with for today, and multimeter. Then it goes to basics of soldering. Finally, we will summarize and we will go for attendance. As far course outcomes are concerned, CO1 we are in. So summarize different types of circuit components. So we are in unit number 1 or module 1. So devices won't come now because devices will be seeing it in the second module. So summarize different types of circuit components with specifications, properties, and applications. It is actually coming under K3 level. If I go for the same course outcome, but for devices, if I am seeing it, it becomes the module 2's course outcome. Now it is for circuit components, right? So I'll repeat again, summarize different types of circuit components with specifications, properties, and applications. This is the actual course outcome. And this is what the module is, basics of circuit components. Today is our 5th class. So first class we had a course introduction. Why we are studying this, what is the need of learning this particular course, what is the importance, or I can say what is the essence of this particular course. Then what is the importance for learning core subjects or core courses. Then we have started with the actual module. So first day after the introduction we had resistors. Then one class we spent for capacitors. Then last class we had sensor and switches. And today, remaining three: relay, multimeter, and basics of soldering. For all these circuit components, what is our plan is to see different types of these circuit components and their specifications we have seen, along with properties and applications. So that's what we are actually doing it. Okay. Coming to what is a relay. So coming to the introduction of relay, as we all know, relay is a electrically operated switch. Electrically operated switch. So for this, you should know first what is the basic difference between electrical and electronics. I think we had this discussion in the last class itself. So electrical means we are going to deal with 230-volt supply, power supply, and if it goes to electronics, it becomes 5-volt or 12-volt. If I use a microprocessor or a microcontroller, whatever it is, as a control unit, then automatically voltage will become either 5 or 12-volt. So this relay is a coil-like arrangement, which is a electrically operated switch. Because whenever the relay has been closed, it becomes a closed switch. If it is open, if it gets stripped off, we will normally say this particular terminology as far as the relay is concerned: tripping the relay, tripping the circuit. Okay, that thing I'm going to call it as a open condition of the switch. So I can say simply as a relay is a switch. It is an electrically operated switch, I can say. And here in a relay, what happens is actually we are going to have electromagnets inside the relay. That electromagnet is going to get operated as a switch. Okay, so many relays use an electromagnet to mechanically operate a switch. But other operating principles are also used, such as solid state relay. What is solid state relay is it is not a mechanical switch or a mechanical relay. Solid state relay means it automatically gets stripped off. Okay, so there is no moving parts in it. So it's not a mechanical switch. Automatically, soft switching will be done there. Okay, so relays are used where it is necessary to control a circuit by a low power signal. That is, if I want to, for example, you assume I am having a circuit in which low power signal or low power devices and high power devices both are combined together to form a circuit for application. You assume this particular situation, right? If in the low power circuit some fault has been occurred, okay, I want to isolate. Both electrical and mechanical isolation has to be done for that particular faulty circuit. Okay, then what I can do was I can operate this particular relay, okay, to isolate completely. Both electrical and mechanical isolation can be done by making use of this particular relay. If I go for separate relays for both low power signal and high power signal. Okay, if I am having separate relays, means I can easily you can isolate them. Okay, you can rectify it, right? So that particular control circuitry we can do it by making use of relays. The first relays were used in where it is used is it is like for long distance telegraph applications as amplifiers. So that is the first relay circuit where it gets used. A type of relay that can handle the high power required to directly control an electric motor or a load is called a contactor. So other name of relay as far as the electrical machines are concerned, we call it as a contactor. Okay, contactor means it is a type of relay actually which will handle high power required to control the electric motor or other heavy or bulky loads like inductive loads or whatever it is. If I want to control it, then I can go for a special type of relay which we are going to call it as a contactor. Again, here some more introduction about relay. Relay is a sensing device which senses abnormal. Abnormal means opposite term of the word normal. If everything is normal, then no problem. If there is some problem, it becomes abnormal. So it is a sensing device which senses abnormality or abnormal voltage and current conditions in the power system and send signal to circuit breaker to remove faulty part from rest of the power system. Faulty part and healthy part. In that way, I can categorize it. So if I want to isolate electrical and mechanical isolation, if I want to do it for a circuit where I want to isolate the faulty section from the healthy section, then this particular relay can be used as a sensing device. Okay, then here a new term comes to you, which we call it as circuit breaker. So there is a difference between fuse and circuit breaker. As the name suggests, circuit breaker is a device which is going to break the circuit whenever there is a fault. Whenever there is a fault, the circuit breaker is going to break the circuit. But the difference is fuse also does the same. Okay, you might have heard something called fuse, wire which is wounded as a fuse, FUSE, fuse. So fuse also is an electrical thing. It's not a device. It is actually a wire, okay, electrical thing, which can be used for breaking the circuit whenever there is a fault. Then what makes the circuit breaker to be different from fuse is that circuit breaker not only it is going to break the circuit, but also it is used to make the circuit again. Okay, that is the speciality about circuit breaker. Normally in our house constructions nowadays, we will be putting one MCB next to or in between main power supply, EB line supply, and to our house. You know, we will be putting one sort of device called MCB, a box. What is MCB? Is actually miniatured circuit breaker. Miniatured circuit breaker. So that is, you assume a condition, you assume a situation that if no MCB has been installed in our house in between power supply and house equipments or appliances, domestic appliances, what will happen if there is any fault in the EB, if there is any fault in the power lines that will directly affect the electrical appliances? You just assume we are having a refrigerator in our house, washing machine may be operated, mixies, grinders, televisions, everything, computers, laptops, everything are getting operated nowadays, right? Regularly, frequently we are operating it. Okay, suddenly if there is some some sort of fault has occurred, some sort of short circuit has been occurred in the EB power lines, what will happen is these electrical appliances will get affected definitely immediately, or I can say suddenly it will get affected. Definitely it will damage the electrical appliances, and our pocket money will get emptied, right? This will happen. So to avoid that only, nowadays the construction of buildings has been done by including this particular MCBs, miniature circuit breakers, in between power lines and electrical appliances. The meaning is that whenever there is a fault, the circuit breaker will protect our electrical appliances, our household appliances, that will be protected by these circuit breakers. That's why circuit breaker, it is very, very important as far as a fault is concerned. Okay, so not only it gets not only it gets broken the circuit, but also it will make the circuit. That we will see whenever we are speaking more about circuit breaker. Now you just remember it is going to break and make the circuit, but fuse is a one which is going to melt itself like a candle, and it will protect the electrical apparatus which are connected beyond fuse. Fuse also does the same thing, but here circuit breaker can remake the circuit also, but fuse will not do that. Okay. First line of defense is provided by the backup relaying equipment. Backup protection operates only when primary protection has failed. So normally in these relay circuits for defense and all, for defense circuits and all, what happens is two types of protections they will be keeping it. One is called primary, another one is backup. Whenever primary fails, then backup protection will get activated, and it will do the same task as that of a primary relay. Again, another kind of introduction is because introduction is important because it is an electrical component. A relay is an automatic mechanical device which senses an abnormal condition of electrical circuit and closes its contacts. These contacts in turn close and complete the circuit breaker trip coil circuit, hence make the circuit breaker tripped for disconnecting the faulty portion of the electrical circuit from rest of the healthy circuit or healthy portions. So the same sort of meaning, what we have discussed and what we have seen from the first two slides, again the same kind of definition has been given over here. What is the principle behind this relay operation? Means a relay may also be called an electromagnetic switch. As I said already, it is the electromagnet which is going to be operated. Okay, operated that particular switch. All right. Relays use a low amperage or low current circuit to control a high amperage, or I can say high current circuit. The low amperage circuit controls an electromagnetic device, and the electromagnetic device either closes or opens the high amperage circuit. It closes means automatically there is no fault in the circuit. That is the actual meaning. And the entire supply goes into the electrical device and it gets operated. Whenever there is a fault, there is a need to isolate or to provide isolation, mechanical and electrical isolation between these parts, then automatically my trip coil or relay should get opened. Then only the tripping operation will take place. Then comes my types of relays. Types of relays means, first of all, we have got definite time relay. Definite time relays are the normal relays actually. Differential relays means, as its name tells, differential. Differential means we are going to have two sort of currents and it is going to make a comparison between those two currents, and whenever there is a difference, okay, difference, it should be zero. If it is zero means I can understand that there is no fault, there is no normality, there is no imbalance. If the value was not zero, it is having some other value, means it means that we have got some abnormality, we have got some imbalance. So that is some fault. That is the actual meaning. Then we have to make the relay to operate and to get opened. Okay, that is the actual meaning. Then solid state relay, as I said, there will be no moving parts, movable contacts or moving parts in solid state relays, and which enables high speed and high frequency operations. So soft relay operation can be obtained by making use of this solid state relays. Then electromechanical relay is just opposite of solid state relays, wherein we have got some mechanical parts in it, like spring, movable armature, electromagnet, movable contact, and stationary contact. Everything will be there. And the spring keeps the two contacts separated until the electromagnet is energized, pulling the two contacts. So that electromagnet only, it is going to be operated. It is going to make the relay to be in a closed position, to act as a closed switch, or to be a open switch. That electromagnet only it pulls off. Remaining kinds of relays which are available are backup relay. As I said, protection. Primary protection. Then we have got backup relay. Current relay we are having. Then voltage relay. Then restricted earth fault relay, that is also available there for the installation of computers and laptops. It is required. Bus bar protection. Then frequency relays. These are the other relays that are available. As far as the advantages are concerned, the electromagnetic relays have very fast operation, very speed operation, and faster reset we can do it. As far as this electromagnetic relay is concerned, this thing can be obtained. The point, if I want to compare it with SSR is nothing but solid state relay. If I want to compare electromagnetic relay with the solid state relay, again, it is very speedy, but reset, it makes the difference. Because we are going to use some microcontroller or microprocessor in the solid state relay portion, wherein resetting the data or memory in the microcontroller will take some time actually. So time lag will take place. So that particular time lag has to be reduced or rectified. Then only the electrical apparatus will not get damaged. Okay. If faulty current enters for even for 30 seconds, right, it will affect the household appliances which are operating. Right. So we have to reduce that particular time. That is why electromechanical or electromagnetic relays, it is advantageous one. They can be used for both the AC and DC systems for protection of AC and DC equipment. So for DC supply and for AC supply, for both the types of supplies, we can use relays. Then they have the properties such as simple, robust, compact, and most reliable. They are the reliable thing, more compact. Compactness is the construction is very robust and very simple. Coming to the disadvantages, the directional feature is absent in electromagnetic relay. So current can only flow in one direction as far as the relay is concerned. The reversibility is not available there. It requires periodic maintenance. Why? Because it is all our movable parts or mechanical parts wherein we are going to have coils in it. So definitely coil may get blown off, may get burned out. So some problems like fire accidents may occur. Okay, so proper and frequent maintenance is required, but it is advantage as far as solid state relays is concerned actually, because for solid state relays no maintenance required, because all are soft things like microcontroller, everything is very soft things. Okay, so there static relays it won't, or solid state relays it won't require maintenance at all. Then relay operation can be affected due to aging of the components, that is due to the depreciation of the components in which we are using, and dust pollution resulting in spurious trips. So if there is no fault also, if there is no abnormality also, sometimes relay will get tripped off. Why that is happening is due to the aging of the component and dust particles. Okay, that also has to be maintained properly. As far as the applications are concerned, electromagnetic relays are employed for the protection of various AC and DC equipments. Then we are having over under current, over under voltage protections of various AC and DC equipments. At that particular place, we'll be using these relays. Then for differential protection, it finds very good application is differential protection. Then it can be used as auxiliary devices in the contact system of protective relay schemes. So if I want to protect something, definitely their relay will automatically come. See, you can keep this particular point in mind whenever you are doing some product, or you are creating some innovative idea, whatever it is, or doing some product or project, whatever it is. Relay, without relay, you cannot achieve, because control circuitry definitely it will have a relay part in it. Without relay, the control circuitry may not get fulfilled. Okay, that's that. So in that way, this particular relay it finds a very excellent part. Okay, this is the first circuit component I want to discuss, right? Okay, have you all understood about this thing? What is it? We call it as relays. Okay. Next, we will go for multimeters. Multimeter, like voltmeter, ammeter, this is also a kind of meter, wherein we are going to measure, or we are going to see or take multiple readings. That is why it has been called multimeter. So ammeter will be there in the meter. We can measure amps in it, amps from multimeter. We can measure volt from multimeter. We can see what is the capacitance value from the multimeter. We can see what is the resistance value, what is the frequency value. Everything we can see it. As far as voltage and current is concerned, both AC and DC we can see it. That is the speciality of multimeter. So what do these meters measure? A meter is a measuring instrument that we know. An ammeter measures current. A voltmeter measures potential difference, or I can say voltage between two terminals or points. An ohm meter measures resistance. A multimeter combines all these functions and possibly some additional ones as well into a single instrument. See, if you see the front panel symbols of a multimeter, its front panel will have all these symbols. And you should understand the different, definitions of all these symbols. See, V, if it is given like this, it becomes a DC voltage, either a straight line, straight sleeping line, or dotted lines like this. Then another V in which a sine wave is drawn, it is meaning that AC voltage. Then if I am having MV, it becomes millivolt. Millivolt in the sense it can measure in the range of 0.001 volt. A means it is amps, MA means milliamps, mu A is microamps, ohm is resistance, kilo ohm, mega ohm, all these ranges. Then I am having some beeper symbol for checking the continuity in the circuit, because once you have soldered some circuit in the PCB, printed circuit board, you have to check continuity. Then only your soldering will get fulfilled. So that particular beeper is also there. Then I am having a capacitance symbol in which I can measure capacitance both in terms of microfarad and also in the terms of nanofarad. Then diode testing is there. Then HZ is nothing but hertz, from which I can get the value of frequency. Then offset reading is there. Range, manual override of auto range is there. Then hold value is there. Then recorded readings, minimum value, maximum value, that particular thing is there. Then dangerous voltage level, that zone is there. Along with that, caution symbol will also be there. So these are all the different symbols that will be available if you see a multimeter. So this is a multimeter front panel. So what I have told in the previous slide, everything you can see it here. So voltages, currents in the order of milliamps, microamps, voltages AC and DC, then capacitance in the order of microfarad, picofarad, nanofarads, so then ohms, kilo ohms, mega ohms, then beep, on off switch, everything you can see it. Okay, and I am having the center portion, which I am going to call it as the selector switch. So using that particular dial, the center one is a dial like thing. So if I do a dial, I can select whichever I want. Okay, so that is the actual thing I want to show you from this particular slide. As far as the types of multimeters are concerned, we are having two basic types. One we call it as digital multimeter, another one is analog multimeter. So digital multimeter will be looking like this, analog will be looking like this. And obviously, what is the difference, between digital meter and analog meter? The same differences will be available here also, because in digital meter, the display will be in digital. Okay, the accurate value I can measure it, but in the analog meter, what happens is human error may happen, maybe like I can call parallax error may happen, because from the meter, if I stand to the left of the meter and if I see the needle where it is standing, it will give you a different value when compared with the opposite one. If I stand at the right hand side of the needle or the meter, if I see the reading, it will give a different value. So that problem will not be there as far as the digital meter is concerned. So digital meters are nowadays very popular. And there is a third type, we call it as fluke type. Fluke type is a special type wherein there is no transient effects will be there. Transient means it is actually short time or short interval effect. Transient means short interval of time. That is, some operation is going on. You assume a situation that some operation is going on, and suddenly I am changing the input. Suddenly I'm changing it. For example, I am testing the resistance value for a circuit using a multimeter. Some resistance is displayed, is getting displayed in the multimeter. Okay. Suddenly, after noting the resistance, if I change it, I'm interested to see the capacitance value. Okay. Suddenly, if I turn the knob, what will happen is it will take some microseconds. It will take some fraction of seconds to display the capacitance value. Am I right? It is quite normal for all the devices. It will take some time, some fraction of seconds. So that particular fraction of seconds is, I'm going to call it as transients. Okay, so I changed the knob to capacitance, but even though for some microseconds, the resistance value will get displayed. Okay, so that is a controversy. I need capacitance value, but the displayed value is a resistor. So that comes a controversy. So that particular effect, I'm going to call it as the transient effect. So that can be avoided if I go for a fluke type multimeter. That's it about multimeters. So once you come to the college, as you are ECE students, you can make use of these multimeters, definitely, because if I am having a resistor, right, color coding and all, how we will normally do it means we can cross verify the answer which you are telling it theoretically. By making use of color coding, you will tell one value for a resistor. That particular value, we can check it with a multimeter, whether the resistance value what you told is correct or not. That we can easily do it. Okay, that is what that is where we are going to use these multimeters. Then comes the last portion, which I am going to call it as basics of soldering. Soldering. What is soldering first? See, soldering is like, welding. See, normally if I am having two iron rods, you think this situation, two iron rods I am having. Okay, I want to paste. Okay, these two iron rods, I want to paste. Okay, or I want to join these two. How to join? Shall I use Feviquick to join to iron rods, or Fevicol, or any other pastes which are available. Shall we do that? We cannot do that. So normally, two big iron rods, if I want to paste them, or if you want to make a joint of those two iron rods, normally we will go for welding operation. Do you agree? So the same thing, if I want to form a metal to metal joint, I have to go for soldering. Okay, if I want to make metal to metal joint, then I have to go for soldering or solder. The joint is made by alloy formation of base metal and solder. In this soldering operation, there are four key elements which we have to remember. One is the soldering iron, we call it as. Then solder itself. Then soldering flux and the component. All these four elements are key elements, are important for the soldering operation to get completed. Okay. Then a special type of wire, we call it as flux core solder wire, is used for hand soldering. Okay. Electronic components, there are three main types of electronic components. Number one, we call it as active component. Number two is passive, and number three is EM. EM is nothing but electromechanical component. Right. Active component. So we all know first what is meant by active element, what is meant by passive element. The same thing, right? Active element means it requires some external source for their operation. Passive elements means it won't require any external source or external supply for its operation. For example, resistor, inductor, capacitor, all these things are passive components. But diode, transistors, SCR, then voltage source, current source, all these things are active components. So in very simple terms, if I want to explain what is active components and what is passive components, active components are energy donors. Okay, so it requires external source, so it will act as a donor, and these passive components will be acting as an acceptor, energy acceptor or power acceptor, I can say. Okay, in simple terms, I can write like this. Okay, what does a flux? We call soldering flux normally. What is the functionality of that particular flux? Okay, so these four operations I am doing it, that is the flux is going to do, right, as far as soldering is concerned. Number one, so if I apply the flux, what it does is it will remove the oxide layer, oxidation. Okay, it will remove the oxide layer in the soldered surface. See, after soldering, I want to get a very smoothened finish, right? Very soft finish I am in need of. For that, I am applying this flux. So remove oxide means remove metal oxide to support wettability of solder. After soldering it, wet portions will be there. So to avoid that, we are applying flux. Number two, it prevents from reoxidation. Reoxidation means that particular flux, there is a chance that it can react with the room temperature oxygen and get oxidized. So if I apply this particular flux, reoxidation will not take place. And number three, surface tension will get reduced. It reduces the surface tension of solder to allow it to spread onto pad or lid. Surface tension, if it get reduced, means wherever I am pasting that particular flux, in the same spot the flux should be there. It should not be spreaded. So for example, if I am having a sponge and if I pour some water into it, and if I touch the corner of the sponge after a few minutes, that particular part also will get a water, right? That means surface tension is very more as far as the sponge is concerned. So water gets spread out everywhere in the sponge, right? That should not happen. That is also a reason why I am going for a flux. Then finally, smooth finish. Make smooth surface finish of solder and prevent solder bridges. Okay, that is the functionality of having this soldering flux. Then comes solder. What is a solder wire? Solder is a fusible metal alloy used to create a permanent bond between metal and metal pieces, or I can say work pieces. And there are normally two main types of solder. One is lead based. Lead based means it is a mixture of tin and lead, and lead free. Lead free means it is a solder without lead material. You can do it. Then comes something called soldering iron. So in the diagram, you can see this is the arrangement of soldering components. I'll be having a soldering iron in my hand. It is looking like a pen here, right? Now, that is the very important thing which is used for making solder. Then I am having some holder to place that particular soldering iron, because initially what I will do was, I have to heat up the soldering iron. Actually, I have to plug the soldering iron to the power supply, and I have to get the heat, because that particular heat is very, very essential to solder the component. Okay, so I cannot touch after or once the soldering iron gets heated up. So I'll be placing in the holder. The soldering iron will be placed in the holder, which is called iron holder, right? Then I am having some sponge here, that is for cleaning the soldering iron tip. Soldering station is nothing but the power supply, wherein I can heat up the soldering iron. The soldering iron is very critical to good soldering. To make good soldering, soldering iron is very, very important. And it must provide all the heat to heat up the joint, which in turn must heat up the solder flux, or I can say solder wire. Okay, so very important point is it must provide all the heat which it has to heat up the joint, which in turn must heat up the solder iron, or I can say solder wire. Okay, that is the important thing which is required again for soldering. And two basic types of solders are, one is called soft soldering, another one is hard soldering. Hard soldering means wherein we are going in for silver soldering and brazing operations now, right? That is the thing I want to speak about relays, multimeters, and soldering. So that's it for now. Any other points, if you are having, you can share it. I'll stop sharing this particular screen. Any other points, if anybody has got, you can share it with me and with our friends. Any points you're having? Okay, otherwise I'll go for some video for 5 minutes, and then we will close our session. Okay, a video I am having it for a multimeter and even for relays and soldering also. Very small videos. I'll try to play that. Please wait for 1 minute. See, I'll be giving some links, some YouTube videos in the chat box for all these things. So first I am giving it for soldering. So if you have got time, you can see to these videos, right? For soldering, this link you can see to that. For multimeter also I am having a link, that also I'll put it. Time permits, you can have a glance on this particular thing. Multimeter video link I have given it in the chat box. Then again, what else we have seen today is relays. Okay, I'll go for relays and I will check for any. Yeah, I am having two videos for relays, right? Maybe if you want, you can have a glance on these two videos. So two videos for relays I am putting it, right? So everything, YouTube links I have given it in the chat box. If you are interested, you can make a note of it and you can go through them whenever required, right? So for time being, now I'll run one video for soldering. Okay, a minute. Okay, so I'll share the screen now. Audio is not required. After completion of the video, if audio is required, then I'll explain you what is happening. Okay. Yeah. Yeah, I hope you can be able to see the video, right? Yeah. Okay, 1 minute. I'll close this video and I will run it in another tool actually. 1 minute. Yeah. Okay, I think this won't work. I'll go to the normal presentation itself, right? 1 minute, guys. I'll go for sorry. Okay, right. One minute, students. Video is getting on. I'll go for the presentation. Yeah, it is here. Yeah, I think you can see. So that's it, a small video for soldering. In the same way, you try to go through the remaining videos that I put it in the chat box, YouTube links. Not only limited to these videos, you can watch any videos, right? Any YouTube videos related to soldering, multimeter, and then relays. So with this, we are closing our first module, and from next class onwards, we will be starting our second module comfortably. Okay.